For this tutorial, we will learn how to build a basic address locator called the dual range US. So we've introduced what we're going to do, right? We're taking Philadelphia, some kind of data that we have, because that's what we've collected. We're going to use, let's open a lighter file. We're going to use information stored in the attribute table to help us either in the case of parcels, right, exactly locate a point, or in the case of roads, locate where it should be along the road. And what are we going to locate actually? Well, it's tables, right? This returns to this idea that if you can have address in tabular form, right, here we have very simply a street and a zip. You can imagine if we were doing something more interesting, maybe these would be locations of certain events, or they could be potential locations where you're going to locate a new store. Right? Anything that has an address, but you're trying to get it out of paper form where we can't do any kind of analysis with it, and get it into some form where we can see it spatially. And so I'm going to zoom into parcels because that's essentially where we're going to see the results. So anytime you want to build a geo or an address locator, right? Because you'll notice if I click on this and I go to geocode addresses, right, a bunch pop up. If you did this, nothing would pop up. So the reason that they're popping up here is because I built a couple to test out some things for these videos. So these are old ones. The military grid reference system is a way that uses military grid coordinates, and the World Geocode Service is essentially ArcGIS's answer to Google, right? So ArcGIS, in its own way, Esri has invested in its own geocoder. It's built it. Some places it's stronger than others. If you want to pay, right, you can geocode. Now you might be saying, well, that's not fair because Google does it for free. But what does Google do for free? Single addresses. What we're talking about is batch geocoding. Right? We want to take, in this case it's only 8, but imagine if you had 500 or 10,000. We want to take all of those and automate them so that we can get the 10,000 records to become spatial data. Right? So in order to get under this geocode an address locator, right, that it's going to reference, we have to first build one. And you build one in Field Calculator. In Arc Catalog. My videos, video data, I've got my address locator updates. I'm going to right click it, go to new, and you'll see address locator. So basically 4 things that are important here. The style, what kind, how is it going to reference? The reference data, what's it going to reference? Right? In this instance, it would be the parcels or the zip code or the streets. Field map, we'll introduce what that is when it comes up. It's a little bit difficult to speak of in the abstract. And the name, what are we going to name it? So first thing we do is pick a style. So click on this. This is a great resource here if you want to follow up from my video. This will explain these in a little bit more depth. But these are the basic styles that come with ArcGIS, right? So you can build one that just uses a city-state. You could build one that just uses a zip, 5-digit zip or zip plus 4. One that just uses a street name, one that only uses a state. You can start getting more specific by doing dual range and one range, right? So this is where you're actually incorporating street data, using the 2 sides of a street. Finally, you could even do single house. Single house is where you start matching parcel data, right? Remember when we looked at the parcel, we saw 3338 West Penn Street. If you know where 3338 West Penn Street is, because it is a parcel, you can match it with single house. So right now we're going to build one of the most common ones, which is dual range. Dual range, as we'll see, is something that incorporates the left and the right sides of streets, right? So the odd and the even numbers of every street. So everything gets populated here automatically. You can see one side of the field map. This is essentially what the address locator needs to do its thing. So it wants a lot of data, but it only needs a couple things, right? The things that are stars. So since we're doing dual ranges, I know that we're going to reference a polyline, right? In this instance, we're going to reference Philadelphia roads. So it'll do its best to match it. This is good data, the Philadelphia roads. The GIS department in Philadelphia takes care. They have named their fields accurately. ArcGIS has built-in scripts where it's really saying, what could from left be. But let's say it didn't show up automatically and you had to match it, right? From left, left from. From left, left from, left to, right from, right to, and finally the street name. If these weren't populated, you would go through manually and you would populate them. Finally, what are we going to call it? basic dual range video. So I'm going to say OK. You're obviously sitting with me through this very boring part. And there we go. So it doesn't look like anything happened. Here I have an address locator, and now I can actually start to use it. So let's right-click. I'm going to go to Geocode Addresses. There it is, the thing we just created, basic dual range. I'm going to pick it. All right, and so my first window kind of pops up. So let's walk through each of the steps. First, where am I referencing it from? Addresses. If I had other tables, I could do that. Single field. If it were single field, I'd have to put the street name and then comma zip. But here I'm saying I have my information stored in two different things. I have street stored in street and zip stored in zip. Every geocoder that you create, whether it's dual range, single range, zip, single address, will have a different prototype of what it needs as inputs. As you work with them and experiment, you'll learn which requires which. What am I going to save this data as? I'm going to call it dual range output. Advanced geometry options, right? When it comes out, what spatial reference, right? Or what rather coordinate systems it's going to employ. You can leave it as is and it'll just take on whatever the address locator that you built was. We never even gave it anything, so it's just going to take on a very basic coordinate system. Or we can use what the map has already. Finally, geocoding options. Spelling sensitivity. I'm not exactly sure how ArcGIS figures these numbers out, but the lower the number is, the more it'll allow misspellings. The higher it is, the more accurate it needs to be. That'll be up to you. Minimum candidate score. You'll see as we move forward, based on how close things are, they're going to get a candidate score. Like let's say, for example, you put 20 West 3rd Street, but the actual address was 20, East 3rd Street. It might say your score is 80 because everything's right, but the West and the East are off. So a minimum candidate score means, right, in order to be considered a candidate, you have to be this score, and a minimum match. You have to at least get an 85 for it to automatically match. Intersections, this allows you to do things like the corner of Schoolhouse and, right, Henry, or Schoolhouse at Henry, or Schoolhouse, little line Henry, or and or at. You would include what you want with spaces in between. Offsets mean once they find the address, right, put it 20 feet off to the side. That way, it's not directly in the middle of the road, it's kind of off to the side a little bit. X and Y coordinates, if you want the X and Y automatically in the table, you can put it, give it a reference ID. This tells you how quickly GIS is moving forward with your geocoder. So we'll hit OK. Hit OK again, it's going to go by in a blink of an eye. Boom. What happened? It matched all 8, no tied and no unmatched. Let's take a look at what rematching actually looks like in case we had to. Right? All of your original fields are here at the end, the street and the zip, and these are the geocoder fields. Right? So what do we get? We got a point. Score, what was the score for those that were matched? Match type, automatic. And what's the match address, right? So what's the address that they're putting each of them at? Right? 3601 Henry Ave is being put at 3601 Henry Ave. Here's an interesting one to compare. The input address was 3360 to 66, right? It had a line in there because it's one of those, join addresses, but the best that it could find was 3360. Notice under candidates, right, because we set that score at 75, a lot of them could be 3341, 3602. It's saying maybe you wanted that, but it automatically joins it to the closest approximate one, particularly if something was a definite. Right, so we can get into how to use this toolbar a little bit more in a later tutorial. Right now we've done a perfect match. So I'm just going to close it, and there are my points, located to the best of their approximation. So what actually happened here? Right, when we talk about the science of how this geocoder worked, this address is 3334 West Penn Street. So what happened here is it took a street that started here and ended here that had a to and a from address, and it estimated where 3334 would fall along that line, where 3340 would fall, where 3338. Now there's a little interesting one, right? That should theoretically be here. Oh no, it shouldn't. Yeah, because it's going from up here down to this way, right? So it starts at 3334, right? Estimates that would have been about 2 addresses, estimates that that would have been about 1, and so on and so forth till you get down here to 3,500.